Hey guys, today we are going to start Chapter 5, Measurements and Calculations. A little bit of this will be a review, but it's important that you understand the concepts that maybe you've learned somewhere else before we learn some of the new things towards the end of the chapter. So if it's review, great, the work shouldn't take you very long, you should be good to go, but just go through the motions, make sure that you understand these concepts. That way, as we move on, you should be prepared and ready to go. So we're going to start out with a little bit of an introduction. Remember, if you had me in 8th grade, we talked about this quite a bit, but we have qualitative data and quantitative data. Remember, qualitative is going to be more like the quality maybe of something, but it's a non-numerical, it's not a number, and it's an observation of something. So it could be things like color, texture, shape, something that doesn't have a number with it. And then you have quantitative data, and think quantitative quantity, so an amount of something or a numerical representation of something with a number. And this could be a temperature reading, mass, volume, age, height, anything like that. So anything with a number is going to be quantitative, and anything without a number is going to be qualitative. Because we're talking about measurements and units, a lot of the things that we're going to be talking about is this second one here, this quantitative. Okay, so we need to have a number, and usually it's going to have a unit with it. Okay, so two types: qualitative, quantitative. Qualitative, quality; quantitative, quantity. Okay, so quantitative observations are often called measurements. And measurements are really important all of the time, whether you're baking, whether you're driving your car, whether you're practically doing anything, you're all the time using measurements, whether you're physically making them yourself, or it's a motor or an ingredient, something that you need a certain amount of. And if you don't get that measurement correct, the motor may not run. You may not stop in the right amount of time, or whatever you're baking isn't going to turn out. So knowing how to measure things and the units and things like that are super important. Measurements consist of two parts. Obviously, the first one is our number, and then the unit is also really important. So from now on, anytime you give me an answer, it should have a unit with it. Okay, so even if it's 9 bowling balls, you still need to tell me it's 9 what. If you just say 9, then I have no idea what you're talking about. So a bad example of giving me a measurement answer would just be saying 5 long. 5 what long? 5 meters long, 5 miles long, 5 centimeters long. How long is it? And then a good example would be 5 centimeters long. So when you tell me centimeters, I'm like, okay, I have a visual idea of how big that is. Okay. So from now on, again, you're going to need to have a number and a unit in every answer that you have. Anytime you have a number, it's most likely going to have some sort of unit. Okay. So now we're going to get into section 1. So far we just did an overview of kind of like what we're going to see in the chapter, but now we're going to get into section 1, scientific notation. And our objective here is to show how very large or very small numbers can be expressed as a product of a number between 1 and 10 and a power of 10. Okay, so we're going to split this section into two parts. So you'll have two separate ed puzzles for this. The first one, we're going to talk about what is scientific notation and how to get numbers into that format. And then the second part, which you'll have a different ed puzzle for, will be actually using scientific notation when we're adding, subtracting, and multiplying and dividing. Okay, so this will be the more of the simpler one, just learning how to put things in scientific notation, and then you'll have another one over the next couple of days that's going to go over how to use them when we're doing math problems. Okay, so scientific notation, the purpose of it is to represent very small numbers, which could be maybe like the size of the atom, because atoms are really, really small. So that's not even really going to be a whole number. It's going to be like a 0.00000 something size of an atom, or really large numbers, which could be maybe the numbers of atoms in an object. So because atoms are so small, there's going to be a lot of atoms in any given object. So we want to represent these really big numbers or really small numbers in a short, easy to read representation. Mostly for a couple of reasons. One, if you wanted to use a calculator when you're doing them, you can't type in all of those zeros sometimes. There's like a max limit on a calculator. This would save that. When you multiply really big numbers or really small numbers in a calculator, it will give them to you in scientific notation. So it would be good to learn how to do them backwards. And it's just easier to see and look at than trying to count all of those zeros or to say how many there are exactly when you're counting all of those numbers. So, for example, if we have this really big number here, so what would this be? Would it be 1,345,000,000,000? I think. I could be wrong, but I think that's right. And then all we're going to do, and we're going to talk about the rules here in a little bit, but just as an overview, all we're really doing for this is moving the decimal. So if the decimal really would be right here. It's not listed, but anytime it's not there, it's always at the end of the number. We're going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay. Our goal here is to get a number to the left of the decimal point that is between 1 and 10. So this one would be 1. So we're going to end up having 1.345 times 10 to the ninth because we moved those decimal places that direction. Now down here, we're obviously going to move the decimal place to the right because we want to get the decimal place where there's a number between 1 and 10. So to get that, we need to move it over here. And we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to end up with 2.3 times 10 to the negative 10. Okay. So if you have a really big number and you make it smaller, it's going to have a positive exponent. If you have a really small number to start out, it's going to have a negative exponent. And there's a couple of different ways that you can remember that. And we'll talk about that here in the next couple of slides. Okay, so here's the format that we're going to have for scientific notation. So the C is going to be any number from 1 to 10, but not including 10. So there can't be any two numbers in front of the decimal place, only one of them. You could have 9.9, but that would still only have 9 in the front. So nothing over 10. And then you're always going to have times 10, and then that n number is going to be how many places you moved the decimal, and it could be positive or negative. Okay. Again, this should be a review. I'm hoping it is, but if you feel you need more explanation than this, let me know and I can do another video, but I am going over it kind of fast because it should be a review. So rules for scientific notation. Rule number 1, all numbers must be between 1 and less than 10. Okay. Rule 2, all exponents on the 10 must be whole numbers. So you can't have like 3/4. It's got to be a whole number because you can't move the decimal 3/4 of a place. You have to move it 1 at least. Rule 3, the exponent on the 10 is equal to the number of places you move the decimal to satisfy rule number 1. So basically, we're just moving the decimal place so that we have a number that is between 1 and less than 10. Okay. Number 4, if the original number is between 1 and 0, the exponent will be negative. Otherwise, it'll be positive. So again, if we have a really big number, the exponent is going to be positive. If the number is less than 1, it's going to be negative. Okay. And then only have as many numbers as you have significant figures. That's going to come into play later. We're not going to worry about this rule yet. So rule 1 through 4, pretty simple, and we're going to practice some here. Okay, so here we go. Let's do a little bit of practice. Let's go with purple-ish this time. Okay, so our first rule was to move the decimal place so that there is only one number to the left of the decimal, and that number is between 1 and 10, but not greater than 10. Okay, so our decimal for this one is going to be right here at the end. It's not listed, so it's right there. And we're going to move it how many places? 1, 2, 3, 4, 5. So we're going to get 2.38. I can drop those zeros. I don't need to relist those. Times 10 to the 5th, because we moved the decimal 5 times to the left. And because this was a really big number, that makes this 5 a positive one. Okay? And again here, if we have 1430, our decimal place is going to be right here at the end because it's not listed. And we're going to move it so that there's only one number to the left of the decimal, and that number is between 1 but not greater than 10. So 1, 2, 3 places. So 1.43 times 10 to the positive third again, because remember this number is bigger than 1. Okay. All right, for this one's pretty big. Again, our decimal place is here though, and we're going to move it how many places this time? Should be 6. So 1, 2, 3, 4, 5, 6. So we're going to have 1.5 times 10 to the 6th. Again, because this was a really big number, our exponent's going to be positive. Okay, and one more of this type. Again, our decimal place is here at the end because it's not listed. And we're going to go 1, 2, 3, 4 places. We're going to do 1.25 times 10 to the 4th. Okay, so pretty simple. All we're doing is moving the decimal place to the left. We haven't talked about the right yet. That'll be on the next slide. But we're moving it to the left however many places so that we only have one number that's in front of the decimal. Okay, and then we just take that number, drop any zeros, times 10 to the whatever number you moved however many spaces you moved the decimal. Okay. Okay, so now we're going to look at some that are a little bit smaller than 1. Okay, this time we're going to be moving the decimal to the right, and that is going to make our exponent negative. Again, because all these numbers are really small, we're going to have negative exponents. So for this one, we need to move the decimal not to the left this time, but to the right, and to the right only one place. So we're going to have 1.35 times 10 to the negative first. Okay, and we did that because we needed to have one number to the left of the decimal. Okay, let's go over here and try this one. This one we're going to move how many spaces to the right? Should be 1.04 times 10 to the negative 6 this time. Okay, again, it's negative because this number is less than 1, and we moved it to the right, and now we have 1.4 times 10 to the negative 6. Okay, all right, another one. This time, how many spaces are we going to do it? 1, 2, 3, and what should our answer be? 1.4 times, or 2.4 times 10 to the negative 3. Okay, and one more. This time we're going to move it 2 spaces. So 3.06 times 10 to the negative 2. Okay, and that is as far as we're going to go for today. So I'm going to have some more practice problems right here on the Ed puzzle for you to try. And then that's all you're going to have to do today. And tomorrow or the next day you have me, we're going to start to use these in equation. So we're going to be adding and subtracting, multiplying and dividing. So make sure that you understand these, make sure that you get a good grasp on how to do these ones. Okay, so if you have any questions or you feel like you need further help or explanation, you can rewatch the Ed puzzle or send me an email and I'll be sure to get right back to you. Okay, I hope you guys have a great day and we'll talk to you later. Bye guys.